in this case, we are going to prove that sin of a plus b is equal to sin a cos b plus cos a sin b. So the first, the main thing that we have to remember in this case is that with complementary angles, if we have sin of an angle A, that's equal to cos of 90 minus that angle A. And similarly, if we have cos of an angle A, that's equal to the sine of 90 minus that angle A. And an easy way to remember this is, say if we have a right angle triangle, and we'll call this angle here A. So because the angles in a triangle have to add up to 180, this angle is 90, so this angle plus this angle here have to equal to 90. So this angle we could call 90 minus A, because this plus this is 90, so this is 90 minus A. So say if we were to label these sides, so X, Y, and Z. If we were to look at angle A as our angle, so the cos of angle A is going to be the adjacent, which is Z, over the hypotenuse, which is X. So Z over X, and the sin of our angle A is the opposite, which is Y, over the hypotenuse, which is Y over X. And then if we were to look at this angle as the one that we're dealing with, so in this case, with this angle, the adjacent is Y, the opposite is Z, and the hypotenuse is X. So for our cos of our angle 90 minus A, the adjacent is Y and hypotenuse is X. For sin of our angle 90 minus A, our opposite is Z and our hypotenuse is X. So say if we're to then compare, so with our formula, sin of an angle is equal to cos of 90 minus that angle. So sin of an angle is Y over X is equal to cos of 90 minus that angle. Yes, that's true. So cos of an angle is equal to sin of 90 minus that angle. So cos Z over X is equal to sin of 90 minus that angle. And yes, that's also true. So we actually do not have to prove out this statement, but I feel like it helps for your understanding. But it's enough to simply state this. So then, because we want to deal with sin of A plus B, we're going to get sin A plus B is equal to cos of 90 minus that angle. So the angle we're dealing with is A plus B. And now we're just going to rearrange this slightly. So we're going to have that as, we're going to put the 90 minus A together in one bracket. 90 minus A. And then we're going to put the B by itself. So the minus B. So we're just grouping the minus, so that minus goes to the A and the B, but we're going to group the 90 and the minus A together. So and then minus B is by itself, and now we have cos. So now we have cos of one angle minus another angle. So this is our first angle and our second angle. So we're going to then use one of our formulae from our log tables, which has a separate proof for it. So that formula is cos A minus B is equal to cos A cos B plus sin A sin B. So we're going to use that formula. So cos A minus B is equal to cos A cos B plus sin A sin B. And if you look back, that was formula 4, that has a separate proof for it. So in this case, for instead of angle A is going to be really 90 minus A, and angle B is just going to be angle B. So if we were to then write this out in this format, so in our case, angle A is 90 minus A, and angle B is angle B. So cos of 90 minus A minus B, so this is the first angle, this is the second angle, is equal to cos of A, so cos of 90 minus A, so cos B, plus sin A, which is sin of 90 minus A, and then sin B. So then we are going to try to tidy this up. So the next thing that we're going to do is we remember that cos of 90 minus an angle is equal to the sine of that angle. So tidying this up, we get cos of 90 minus A is the sin of that angle, so sin of the angle, and then bring the cos of the angle, and then sin of 90 minus A is cos of that angle, and then sin B. So we started off with sin A plus B, and then we let that equal to this, and then we got that equaled to this here. So overall, sin A plus B is equal to sin A cos B plus cos A sin B. And that is our proof. So what is required is, we don't require this explanation here, but it just helps for your understanding. So it's the bottom part that's necessary for our proof, so for this identity.